question is, how do you find the zeros of quadratic functions? There are various ways. It comes down to basically three ways. There's actually a fourth where you complete the square and get the standard form. Okay, but that's just a method for going from general form to standard form. Okay? So it really, your quadratic formula comes out of that process. We won't worry about that. Maybe we'll never worry about that. Depends on how we're doing with everything else. Okay? Hopefully we get to worry about that a little bit. Okay, so in the general form, where your zeros are at x equals this. I got in a hurry with that A and made a bad one. It looked like a G. Okay. It's that simple. I could say more about it. I'll just mention, depending on this discriminant, you can have 2, 1, or no real zeros. Okay? You get 2 real zeros if b squared minus 4ac is greater than 0. Now we said all this, but now it's time to really lock it in, okay? b squared minus 4ac equals 0. You only get one real zero. And that's going to be negative b over 2a. Because, of course, if this is 0, all you're left with is negative b over 2a. And in that case, your 0 is on the axis of symmetry. Your 0 is also on the x-axis because that's where the zeros of a function occur, meaning that your graph sits or is suspended from, depending whether a is positive or negative, on the x-axis. Okay, from a point on the x-axis or sits on a point on the x-axis. Okay, so two complex conjugate zeros if b squared minus 4ac is less than 0. This means that there are no real zeros and the graph doesn't intersect the x-axis. Meaning, if a is positive, it's above the x-axis. If a is negative, it's below the x-axis. Okay? This is what the zeros tell you. Now, your original question was just how do you find them, but naturally I'm going to add stuff that you really should know. You don't necessarily know what complex conjugate zeros are. That's the first section of the chapter, and it's the easiest section in the whole book. So we'll pick that up shortly. But that's one, except for dividing two complex numbers, everything is easy. Okay? If you know the distributive law, which you do because I've been beating it into you for 2.5 months now. Okay. And I think it's been effective. People are pretty good with that. Okay, well, that's how you do it for the general form, and that's what you learn from the quadratic formula, right?
Actual question.
Yeah.